when we started out and we were solving these examples that we started out with, they wanted all real numbers. So all of these had to have plus 2 pi k, or plus pi k, or plus 360 k, or 180 degrees k. So if it says on your homework or on the test, if somebody wrote a test that said find all real numbers, then that is testing whether or not you're paying attention to the directions. Okay? So the directions here say all real numbers. If the directions say that, then you are always going to have to put on the plus 2 pi k, plus pi k, or plus whatever the degrees is equivalent. In these that we are working on down here, these do not have that. In fact, it tells me I want to have all the real numbers in a particular interval. So if I have that, then what I'm looking for is all real numbers on the unit circle that make that true. So I'm only looking at the values that make this true on the unit circle. How far did we get yesterday? Question A. So not very far. Which one of these three would you like me to do? D? Oh, I did E? Okay, so which one of these would you like me to start out with today? Because then you'll do the other ones. D? You want me to do D? Or you want me to do A? Okay. So if I take a look at D, the first thing I'm going to do is I need to isolate my sign. So I'm going to take the 1 and bring it to the other side of the equal sign. So 2, the sign 2x is equal to -1. Now I'm going to divide both sides by 2, and I end up with the sign 2x is equal to -1/2. Now I look on my unit circle, and I find where the sign is equal to -1/2 on the unit circle. I'm ignoring the 2x right now. I just want to know on the unit circle where the sign is equal to -1/2. 7 pi over 6. (11 pi divided by 6). Now, I'm ignoring that 2x. I am not, because I love myself, I am not going to do the double angle for that. If I introduce the double angle, then I'm introducing both sine and cosine. Terribly difficult to solve for it when I have sine and cosine. So I'm going to set this 2x is equal to those two angles. And that's how I avoid doing the double angle. So now, and you'll notice on this, I did do the plus 2 pi k, and the reason I did that is because my angle is not just x. If my angle is just x, I don't have to do that plus 2 pi k, I can just give you the answer. But because it is not just x, or it's not just theta, it's not just gamma, it's not just a single variable there, it is 2 times that variable, I do have to put the plus 2 pi k. The reason I do that is because now I have to divide every single term by 2. Because I am solving for x, I'm not solving for 2x. So I'm going to divide this by 2, I'm going to divide this by 2, and I'm going to divide this by 2, and the way I'm going to do that is with a multiplication. Multiplying 1/2 is the same thing as dividing by 2. So I end up with x is equal to 7 pi over 12 plus pi k. And I'm going to do the same thing to the other one. So I'm going to divide this by 2, divide this by 2, and divide this by 2. And so I get x is equal to 11 pi over 12 plus pi k. The reason I have to do this is because I am now going to go through iterations of k equals 0, 1, 2, 3 on up until I come out of the unit circle. So when k equals 0, I get x is equal to 7 pi over 12. That's in that interval, I am good to go. When k equals 1, now I'm just going to go back up here and rewrite my pi k to have the same common denominator to make my life easy. So to make my same common denominator, I'm just going to go back up here and just rewrite this as 12 pi k over 12. The only reason I'm doing that is so that I can add my fractions quickly and easily. So if I put k equals 1, then I'm going to have 7 pi plus 12 pi. When I add 7 pi plus 12 pi, what do I get? Am I still within the interval 0 to 2 pi?
Yes.
Yes. I'm going to do k equals 2. If I do k equals 2, I'm going to get 24 plus 7. Am I still in there? So I don't have that one. Now notice I only did it for the one angle. Now I have to do it for the other angle. I'm going to do the same thing on the other angle. I'm going to take my pi over pi k, and I'm going to rewrite pi k again as 12 pi k, black and black. So 12 pi k over 12. The only reason I'm doing that is so that I can find my angles quickly, because I have to go through the iterations of k. So I start out with k equals 0 on this one. When k equals 0 on this one, I'm going to get 11 pi over 12. When k equals 1 on this one, I'm going to get 23 pi over 12. Am I going to do a k equals 2 on this one? No. So because of the fact that I did not start out with just an angle x, an angle beta, an angle alpha, I have to go through this process. And when I went through this process, I actually have 4 answers. I have these, and I have these. Now I'm going to stop a minute. I'm going to expand this out so you can all see where I started. And then I want you to ask me some questions. So I'm going to put this on pause, and I want you to ask me some questions. Why do I have this 1/2 right there? So the reason I have that 1/2 right there is because I have to get my x by itself. I have to isolate x. That means I need to divide everything by 2. When I'm dividing by 2, it's the same thing as multiplying by 1/2. So every term needs to be divided by 2, and since I already have a fraction, do it as a multiplication of 1/2 versus division, because it's already a fraction. Yes? Yes?
You probably said this when I was angry, why aren't we going beyond K1? Why don't we go to K2?
So the question is, why don't I go to K2? And that's because I have to stay in the interval between 0 and 2 pi. So if I use k equals 2, then I have a number that's outside of 2 pi, so that's why I don't use 2. Yes?
So you said that we only do this whole process because x has a constant or something attached to it, or whatever variable we're using. So if it was just like sine of x, we wouldn't have to go through this whole thing. We just find where it equals negative.
Absolutely.
Just be your values.
Yes. So the question is, the reason I did this was because my angle wasn't just x. Now, if my angle would have been just x, so let's just do it as just x. If I would have just had the sine of x is equal to negative 1/2, my angle here is just x, or just alpha, just beta, just y, whatever it is as my variable. Then my answer here, I don't have to do this plus 2 pi k business. It is just going to simply be 7 pi over 6, 11 pi over 6. And that's because my angle is singular. It doesn't have anything else attached to it. It has a coefficient of 1. So that's all you have to do. But because this one did have a 2 on it, I do have to do that extra step of doing plus 2 pi k and then doing the divisions out. Yes?
Why do you add the 12 pi k over 12 to the 7 pi over 12?
So the reason, the question you're asking is, why did I add the 12 pi k over 12? Well, when I went at this step right here, when I divided everything by 2, that ended up being pi k. And because I have to add multiples of pi k, I'm going to add multiples of pi k in such a way that it's going to make my addition of fractions the easiest. So what I know is that pi k can be rewrote as 12 over 12 times pi k, or in other words, 12 pi k over 12. And the reason I did that particular step is because right here has a denominator of 12. If that would have been a denominator of 17, then I would have had multiples of 17 pi k over 12 over 17. So all I'm doing is I'm making my fraction addition a little bit easier than it would have been if I would have just left it as just pi k. Anything else? Yes?
Just to clarify, for the final step, when you circle your answer, you have 7 pi over 12 and 19 pi over 12. Once you've found that LCD, you know that it's k equals 0, k equals 1. It's just the sum for the second answer.
Yes, so the clarification question was, so the 19 pi over 12 came from the fact that you did put in 0 for the first one, but the second one I did put in 1 for k. So to get this second one right here is I did 7 pi over 12 plus 12 pi multiplied by 1, because that k is 1 over 12, and that gave me the 19 pi over 12.
Okay.
Got it? Anything else? These are really good questions. Or anything else? Because I'm going to let you try some of these other ones on your own.
Yeah, how did you go from there to 11 pi over 12 and 23?
So there are two separate things going on here. There is this part, and then there is this part. There are two separate angles initially that when I take the sine of an angle equals negative 1/2. There are two angles that initially have that happen in the unit circle. So I am working two problems simultaneously. Yes?
So if we have like a problem on the test that says like find all real numbers in the interval and gives us this interval, this is how you solve it.
So the question was, if I have it in all real numbers, just all real numbers, I actually get to stop right here. But because I'm required to go in a certain interval, I actually have to find the specific angles that works for. Does that answer your question? Okay. Anything else? These are really good questions. Anything else? Because you're going to run on some of these yourself. Okay. So what I want you all to do, since I've done E and D, I want you to do A, B, and C. So I'm going to give you about 5 to 7 minutes to do A, B, and C. So let's take a look at A. And I'm going to go to my unit circle, and I'm going to look to see where cosine is equal to 1/2. Where is cosine equal to 1/2? So when my angle is equal to, what is it? Pi over 3 plus 2 pi k. Now remember, I have to do this because my angle is not just x or alpha or beta. And then my other one was 4 pi over 3? 5 pi over 3? Okay, now I'm solving for x. I'm not solving for x over 2. I put x over 2 there, but I'm not solving for that. So I'm going to go ahead and multiply everything by 2 to get rid of that denominator. When I multiply everything by 2, then my first one is going to give me x is equal to 2 pi over 3 plus 4 pi k. Do you think I'm going to have to do the k equals 1, 2, 3 up? No, because this addition is already 2 full revolutions, so you don't have to worry about that one. I'm going to do the other one as well, and when I do the other one, I've got x is equal to 10 pi over 3 plus 4 pi k. And again, I don't have to worry about doing the revolutions because that's 2 revolutions and that's way outside of my interval. The other thing is I look at the angles that I have. Is 2 pi over 3 within the interval from 0 to 2 pi? What about 10 pi over 3? No. So even though I came up with that answer, my only true answer on this is 2 pi over 3. That's it. It's the only true answer I've got. Okay? Any questions on that? All right, let's do B. So the tangent of 4x is equal to 0. This happens in 2 places. Where are the 2 places this happens? Multiples of pi, right? So 0 and pi and 2 pi and 4 pi and 3 pi. So I'm going to just write this as pi k. Is that okay if I just write it as pi k? Now I only have, because it's tangent, and they are away from each other by a multiple of pi, I don't necessarily have to break this into 2. So I can just leave it like that. Now I'm going to divide both sides by 4, and I get x is equal to pi 4k, or pi k over 4. I do have to go through, though, and find k equals 0 on up. So x is equal to, when k equals 0, I get 0. When k equals 1, I get pi over 4. When k equals 2, I get 2 pi over 4, which is just pi halves. When k equals 3, I get 3 pi over 4. When k equals 4, this fun never ends, I get 4 over 4, which is just pi. When k equals 5, I get 5 pi over 4. Oh man, this is so much fun. When k equals 6, I get 6 over 4, which is 3 pi over 2. When k equals 7, I finally get to stop 7 pi over 4. I finally get to stop at that point. How was that? That was delicious. Now, here's the thing about tangent. Tangent, cotangent, secant, cosecant, there are places in which it is undefined. Because there are places in which it's undefined, all of these answers you have to check to make sure they are not extraneous. Exactly, the joy and fun never ends. So now I'm going to check it. So I'm going to check my first one. Here's my check. I have to check these because there are places on the unit circle in which tangent, cotangent, secant, and cosecant are undefined. So I'm going to check it. I'm going to do the tangent of 0 times 4x. So this is the tangent of 0. Can I do the tangent of 0? Can I do the tangent of 0? Yep, I'm good on that one. I'm going to do the tangent of 4 times pi over 4, which is the tangent of pi. Is that okay?
Yes.
So that one's okay and that one's okay. Now I'm going to do the tangent of 4 times pi over 2, which is the tangent of 2 pi. Can I do the tangent of 2 pi? We were hoping for a no. No. So you do have to check these. These will all check out because they are multiples of 4 here. All of these, it started out with multiples of 4 and then dividing by a 4. So all of these will check out. So there isn't going to be any problem with it, but you do have to check tangent. So tangent, cotangent, secant, cosecant. These will all check out. I'm just letting you know they will because I want to save time. Okay, lastly, we are going to do C. And C is the one I would have recommended that you start with. And the reason I would have recommended that you start with C is because for C, there is no worry about doing the plus 2 pi k stuff because there is no multiplier on my angle. So I just have the sine, do this in black. So I just have the sine to the sine of alpha is equal to negative square root of 3. Divide both sides by 2, sine alpha is equal to negative square root of 3 over 2. And I just get the answers right away. There's no work on this one. There's no extra work on this one. So where is, on the unit circle, where is the sine of alpha equal to negative square root of 3 over 2? 4 pi over 3 and 5 pi over 3, and I get to walk away pretty happy. And I was able to do that because there was no multiplier on that angle. Every time there's a multiplier on that angle, I have to do that extra work. This one did not have a multiplier on the angle, so I just get to say, hey, here's my answers. All right? All right. What about these? Which one of these would you like me to do? Okay, let's do L. Now, when you are looking at L, what does the left side look like? Not double angle, sum and difference. So this is going to bring in all your identities that you are trying to forget, as well as your algebra skills. So this is the sum and difference. What this, on the left-hand side, this part right here is equal to the tangent of 3 beta minus beta. That whole left side gets combined into 3 beta minus beta. It equals the square root of 3. So what I really have is the tangent of 2 beta is equal to the square root of 3. Now remember, tangent has period of pi, so all I have to do is find one angle that's true because the other one will be a period of pi away from it. Where is the tangent equal to square root of 3? pi over 3. So 2 beta is equal to pi over 3 plus pi k. Now, I have a 2 as a multiplier, so I do have to divide everything by 2, which is multiplying by 1/2 when I already have a fraction. So beta is equal to pi over 6 plus pi k over 2. Now, what do you think I'm going to do with that pi k over 2? I'm going to get the denominator the same, first of all, before I start putting in values for k, so it makes my addition of fractions easier. So I'm just going to take that pi k over 2 and make it equivalent to 3 pi k over 6. That allows me to make my additions fairly quickly. So where I am right now is I am at beta is equal to pi over 6 plus 3 pi k over 6. So beta is equal to k equals 0. When k equals 0, what do I get? Pi over 6. When k equals 1, what do I get? I get 3 pi over 6, which is I get 4 pi over 6, which is 2 pi over 3. Right? Got to check my fractions. I'm pretty sketchy. When k equals 2, what do I get? When k equals 3, what do I get? 5 pi over 4, because it was 10 pi over 6 and it gets reduced. When k equals 4, am I outside my interval? Yes. All right. Those are my answers, and now I need to check them in the original one. What I'm looking for in the original one is places in which it makes it undefined. My original one, let me write it again, is the tangent of 3 beta minus the tangent of beta 1 plus the tangent of 3 beta tangent beta. Now what I mean by checking it is I'm going to look. If I put pi over 6, 2 pi over 3, 7 pi over 6, 5 pi over 4 in the tangent beta part, do I have any issues there? Where are my issues for tangent? Where am I undefined for tangent? There are 2 places on the interval that I'm undefined. Where are those 2 places? So I'm going to make sure that I am not doing the tangent of pi over 2, because that's undefined, and the tangent of 3 pi over 2, because that's also undefined. So if I put any of those angles in this part of it, I'm good. All of those angles are cool. I can use all of those angles. Are there any of those angles that when I multiply it by 3 will give me pi over 2 or 3 pi over 2? Are there any of those angles that I listed that when I multiply it by 3, that'll give me pi over 2 or 3 pi over 2?
2 pi.
So 2 pi over 3. If I took 2 pi over 3 and multiplied by 3, I get 2 pi. Can I take the tangent of 2 pi? Yeah, I'm cool there. So if I take pi over 6 and multiply it by 3, I get pi over 2. Is that okay? That is an extraneous solution, because I can't take the tangent of pi over 2. What do you think my other one is going to be? Say it louder. Say it louder. Well, let's try it. So 5 pi over 4 multiplied by 3, is that going to give me a multiple of pi over 2 or 3 pi over 2? Nope, that's okay. What else? So 7 pi over 6 multiplied by 3 is going to give me 7 pi over 2. Is that okay? No. So even though I came up with 4 solutions, 2 were extraneous.
Why 7 pi over 2?
Because 7 pi over 2 is either straight up or straight down. So pi over 2 is up, 3 pi over 2 is down. 5 pi over 2 is up, 7 pi over 3 is down. So it is a multiple of the 3 pi over 2. So, and I can't take the tangent of 3 pi over 2, which means I can't take the tangent of 7 pi over 2, or 9 pi over 2, or 21 pi over 2. So any pi over 2, I can't take the tangent of because it's undefined. All right. Which other one, since we're on a time constraint, would you like me to do? M? So on M, I have 8 cosine to the 4th theta minus 10 cosine squared theta plus 3 is equal to 0. Hopefully, your pre-calc 1 professor told you the importance of u substitution. Let u equal the cosine squared theta. Because if you haven't learned it, now is the time to learn it because you'll need it for calculus. So let u equal. And this is a quadratic type equation. This looks like a quadratic. I have 3 terms. And it looks like something squared minus something not squared plus some constant. This looks like a quadratic, so I'm going to treat it as such with u substitution. So then u squared is cosine to the 4th theta. So now I have a replacement for cosine to the 4th and cosine squared. So this is equal to 8u squared minus 10u plus 3. Can you all factor that? What does this factor into? Positive 5 and negative 2? Well, I can tell you 3 has to be 1 and 1 has to be 1. I can tell you that part because that's prime. That has to be 3 and 1. So now I just need to break up the 8 into 1 and 8 or 2 and 4. One and 8 and 2 and 4. Does that work? Does that give me 10 when I multiply everything through? Gotta work on my poker face. Does that give me 10 when I multiply through? Okay, so what I have is u is equal to 1/2 and u is equal to 3/4. Do you agree to that? Am I solving for u, however? No, I am solving for cosine squared. So cosine squared theta is equal to 1/2 and cosine squared theta is equal to 3/4. How do I get rid of the squared? So I have to take the square root of both sides. Now remember, you have to use the plus and minus in the appropriate place. So what I end up with is I get the cosine of theta is equal to plus and minus the square root of 1/2. The cosine of theta is equal to plus and minus the square root of 3/4. So the cosine of theta is equal to the square root of 2/2 plus and minus if you rationalize that denominator. Cosine of theta is equal to plus and minus the square root of 3/2 when you rationalize that denominator. So theta is equal to, tell me all the places on the unit circle I get a plus and a minus square root of 2/2. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Oh, and I said 6. 7 pi over 4. And that takes care of that one. Just a minute. My other one, where is my theta equal to square root of 3/2 plus and minus? Pi over 6. 5 pi over 6. 7 pi over 6. 11 pi over 6. Do I have to check these? Big no on that one because I don't have any issues with cosine. Cosine is defined entirely on the unit circle. The cosine domain is negative infinity to infinity with no restrictions. Yes?
Wouldn't the square root of 3/4 break down to the square root of 3/4?
The square root of 4, right? Square root of 4 is 2. So the question you asked me is the square root of 3 over 4. Well, this is equivalent to the square root of 3 over the square root of 4, which is the square root of 3 over 2. Okay, I'm not done yet. I do need to do another one. I need to show you how to do another one. Now, I'm going to look at G. G has both tangent and sine, and their angles are not the same. The same thing with H. So it has tangent and sine, and you cannot divide both sides by tangent x because you have just lost a solution. You can't just arbitrarily divide by a function. It just doesn't work. I had my calculus student says, I can do this. I said, no, you can't. You can't do that. So what you can do on G and H and on I, see I has the problem too and J has that problem. They all either don't have the matching angles there or I have more than one trig function in play. So what I have to do is like I did with L is I have to use my trig identities. So tangent of x, the sine 2x, is equal to 0. Well, I'm going to take my sine 2x and I'm going to write it as the double angle, and I'm going to take tangent and write it as sine cosine. So tangent is the sine x over cosine x, and sine 2 theta is 2 sine theta, or sine x cosine x. Now I get to do some cancellations. Now what happens is my cosines cancel, leaving me 2 sine squared x is equal to 0. Divide both sides by 2, take the square root. On J, I have tangent squared and cotangent squared, so you choose which one you like the best. And you're going to write one as the other. So on J, if you like tangent best, then you're going to write this as the tangent squared sigma minus 1 over the tangent squared sigma is equal to 0. Then what do you think I'm going to do at that point? Multiply everything by what? Tangent squared. This one has a mix of sine and cosine. You can do the same thing. So it is going to be the sine, 2 sine x cosine x is equal to 3 sine x. Bring everything to one side. You get 2 sine x cosine x minus 3 sine x is equal to 0. Factor out a sine x. And then you have 2 cosine x minus 1 is equal to 0. You set each one of those equal to 0. Have a great day. We're done with this section. All right, so now let's talk about solving trig inequalities. Let's take a look at A. So for A, I'm asked to find the tangent of x to be greater than or equal to the square root of 3. And I'm going to take a moment and think about the graph of the tangent. So the graph of the tangent, at pi over 2, we have a vertical asymptote. At 3 pi over 2, we have another vertical asymptote, and etc. So if I look at only the interval between 0 and 2 pi, then the graph that I have looks like this. And that's only looking at from 0 to 2 pi. So that's what's the tangent graph looks like. So we know that on the unit circle, the tangent of my angle is equal to square root of 3, that when I am at pi over 6. So right here, when I'm at pi over 6, I'm at the square root of 3. And then again over here in quadrant number 3, which is 4 pi over 3. Sorry, this should be pi over 3. Sorry, let me go back. This should be pi over 3. So that should be pi over 3. So pi over 3, and then again at 4 pi over 3 is when I'm at the square root of 3. So if I think about it, that at here is where we have y is equal to the square root of 3. So any value that is on the tangent in this region is going to make that a true statement. So my solution for A is going to be an interval, and the interval is going to be from pi over 3 to pi over 2, non-inclusive because I have a vertical asymptote, and then I pick it up again at 4 pi over 3, inclusive, to 3 pi over 2, non-inclusive because of the vertical asymptote. So if I think about it in terms of the graph, then I can clearly visualize the solution. Let's take a look at the second one. So I have the sine of x is less than or equal to 0. Again, I'm going to think about the graph. That's what the sine graph looks like. So at pi, at 2 pi, pi over 2, 3 pi over 2, it looks like this. It goes up, and then it goes down, and so it comes up to 1, and it goes down to -1. And I want to know where I am less than or equal to 0. Well, on my sine graph, my values that are less than or equal to 0 is between pi, inclusive, to 2 pi. And it's non-inclusive because it's in that interval, so from here, it's non-inclusive of 2 pi. So if I think about it in terms of the graph, these are the angles or the x values that give me a negative answer. Now this entire time, what I've been doing is I've been looking at the graph, but I don't have to look at the graph. Let's do it by solving. So the sine of x is equal to 0 when x is equal to pi and when x is equal to 2 pi. So if I then break this up, just like we did in pre-calc 1 in terms of a sine graph, then on just a number line, I have pi, I have 0, and I have 2 pi. And then here's my sine of x. I'm going to choose a value in here that I know, so I'm going to choose a value in this interval, which is between 0 and pi. So I'm going to choose pi over 2. Well, the sine of pi over 2 is positive. So then I'm going to choose something in this interval between pi and 2 pi. And I'm going to choose 3 pi over 2. Well, 3 pi over 2 is negative. So I can see the region in which my interval is negative. It is between pi and 2 pi. Now the reason I'm bringing that up is because when I look at C is going to be a little bit more challenging. So let's take a look at C. And I mean challenging in terms of graphing it. So we have the cosine squared of x is equal to 1/2. So I'm going to go ahead and solve this, and so I've got the cosine of x is equal to plus and minus the square root of 1 over 2, or in other words, plus and minus the square root of 2 over 2. So I have to break this up into the intervals in which I have the square root of 2 over 2. Well, those are at pi over 4, at 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, so after we broke this up into its different regions, again, I have the interval between 0 and pi over 4, the interval from pi over 4 to 3 pi over 4, from 3 pi over 4 to 5 pi over 4, and then my last, well, I guess I have a couple more, 5 pi over 4 to 7 pi over 4, and then my last one from 7 pi over 4 to 2 pi. All right, so now I'm going to choose any angle in this first interval. And so remember, I am checking it against cosine squared. So I have cosine squared of my angle. I'm going to choose anything in there. Let's choose pi over 6. So if I choose pi over 6, the cosine of pi over 6 is the square root of 3 over 2 multiplied by the square root of 3 over 2. It's a really bad looking square root of 3. Square root of 3 over 2, which gives me 6 over 2. Excuse me. Which is larger than the square root of 2 over 2. So I know that this interval here between 0 and pi over 4 is going to be part of the solution. I'm going to choose some angle in here. I'm going to choose pi over 2 because it's the easiest. Well, the cosine of pi over 2 is 0. 0 multiplied by 0. Well, that's clearly less than pi square root of 2 over 2, so we know that's not part of the solution. I'm going to choose something between 3 pi over 4 and 5 pi over 4. Let's choose an easy one. Let's choose pi. So that is negative 1 multiplied by negative 1, which is 1. And 1 is larger than the square root of 2 over 2. So that's part of my solution. Between 5 pi over 4 and 7 pi over 4, I'm going to choose an easy one. I'm going to choose 3 pi over 2. Well, 3 pi over 2 is still again 0, so 0 multiplied by 0, which is 0, which is strictly less than square root of 2 over 2. So we know that's not part of the solution. And then I'm going to choose something in my last interval. I'm going to choose, say, 11 pi over 6. Well, 11 pi over 6, again, is square root of 3 over 2, multiplied by the square root of 3 over 2. And that is larger than 1/2. Or excuse me, the square root of 2 over 2. So my solution to this particular problem is, and this is non-inclusive, it will be from 0 to pi over 4, union between 3 pi over 4 to 5 pi over 4, union between 7 pi over 4 and 2 pi. So that's pretty much how you do these. You can think about it, the graph of these, or you can do an interval chart, a sign chart like I did here, and that's how you solve the inequality trig functions.